Hello, I'm Niall, and I'm on Team Charlie, and we worked on the Intelligent Graph Reader for Sparrow. Now, Sparrow noticed that services like Google Scholar allow you to search like the web for, or search anything, for instance, for data based on textual information, but not on data from like images and graphs and such like. So, in order to sort of explore what you can do with data and graphs and images and that sort of thing, our brief was to develop document analysis software that would be fed HTML or PDF research documents and would then extract graphs from those documents and would then try and extract as much information from those graphs as possible. So for instance, axis headers, trend data from the actual graph itself, and then would be able to feed that information into a database which can then be queried. So our approach to this was to treat it as a pipeline. So essentially you would have, at the beginning, you would feed in the research document into the image extractor, which would then extract all the images from the document. These images would then be fed into the preprocessor module, which would do things like, for instance, an image of multiple graphs. We plan to have that split that image into individual graphs. We also ran some filtering on it to make it easier for the classifier to then classify the graphs according to whether or not they were a graph in the first place and what type of graph they were, if they were indeed a graph. And we plan to do this with basically a machine learning algorithm, which would have a training set of graphs of different types and would match the graphs that we extracted against these types and decide whether or not they were graphs in the first place or whether or not they matched up with graphs that were in there of certain types. Then this information would then be fed to the trend detection and OCR module, or optical character recognition module, which would then try and read textual information from things like the axis headers and would try and detect the trend in the graph if it was possible. So for instance, for a line graph, we would try to see if we could tell if that line graph was increasing or decreasing. So the idea with this then is that output, like that metadata output, would then be essentially be able to go straight into a database, which then could then be queried based on the metadata, which would then act as tags for a search engine. We faced some problems along the way, one of them being that HTML is actually not a practical format for this sort of thing, given that HTML documents tend to have low resolution images that link to high resolution images. So that was not really feasible, so we had to restrict our scope to PDF documents. We also found that classifying images is actually quite tricky. It's a bit trickier than we thought it would be. It turns out that you need thousands and thousands and thousands of images in a training set to really end up with a very accurate classification system. We had, in the end, about 100. So it meant that it ran quite quickly, relatively quickly, in the demonstration session, but it unfortunately meant that some of the classifications were a bit off. But at the same time, we were relatively accurate in terms of being able to classify whether or not something was a graph or not. We had some issues with libraries and compatibility as well. Like, for instance, we were running various systems, running sort of different operating systems and machines, and we had the issue of, given that we were using quite a lot of libraries, we were using OpenCV for the for the filtering and the computer vision tasks. We were using like a lot of some libraries for the databases, libraries for the OCR, such as Tesseract, and we were using Lucene for the information retrieval, and we found that made it very difficult for us to make sure that we had the project running on all of our systems, which made things difficult as well. We also had the issue of having to work out exactly what these libraries could do, so that restricted our ability to maybe work on like the code itself. And of course, along the whole way, we were really quite unsure whether or not what we were doing was even possible, given the sort of abstractness of having to just classify graphs in that sense. But it turns out a lot of it was actually quite possible, because we were able to actually extract the images from PDF documents, split those images into images of multiple graphs if they were multiple graphs, classify the graphs with a best guess sort of classification based on the training set that we had into either line graphs, line scalar graphs, bar graphs, or non-graphs, in which case they would not be read, or would not be read in the OCR or trend detection. We were able to attempt to detect trend in line graphs and scalar graphs. Line graphs in particular, we were able to get quite an accurate reading for whether or not it was increasing or decreasing. And we were able to basically read axis titles as well, and were able to feed that into the database. So we were then able to, of course, search on the information extracted and output images that matched search terms based on sort of precedence in terms of how many search terms they matched based on the tags extracted. So as an example of the information we were able to actually extract, if you take a graph such as this, we were able to extract the fact that the x-axis header was false positive rate, the y-axis header was true positive rate, there was a line graph, and that it was increasing. So thank you very much for listening.